Fine, sir.
Fine, sir.
So today we will start a new topic. Topic name is sensors and transducers. Sensors and transducers. So what is a sensor? Have you how many sensors are there in our human body?
Five
Five. Which are the five senses?
tongue, eyes, nose, eyes, ear, or skin.
So from this, it is clear that function of the sensor is to convert or produce a change according to some physical change. According to some physical change. So today's objectives. That means objective means after this class you should be able to explain. This is the objective. Study the function of a sensor. Study the function of a sensor. What is a signal conditioning unit? Third one, data representing unit. Fourth one, difference between sensors and actuators. Fifth point, classification of transducers. This is the objective of this session. So sensor, as we discussed, sensor should detect changes in physical quantity. So which are the physical quantities? Temperature, pressure, level. उसमें change आने समय detect करना चाहिए. Then after detecting, it should be reflected as change in output quantity. पहला detect करना चाहिए. उनके बाद it should be displayed. It should be reflected as output. Then second part, signal conditioning unit. So physical output, that means from the sensor we will get an output. It has to be converted to electrical quantity. So this will be done by signal conditioning unit. So this is nothing but in order to get an idea what is a sensor, four sensors photo, just photos, RTD, resistant temperature detector, in order to measure temperature, thermocouple, also used for measuring temperature, thermistor, likewise charge sensors. In a measuring system, suppose I want to measure a quantity, an electrical quantity, there should be a sensor and a signal conditioning unit. Sensor and signal conditioning unit put together is known as transducer. So sensor will detect the change and it will be converted by the signal converted into electrical signal by signal conditioning unit. That output, that electrical output should be displayed. For that purpose we are using LCD. Sometimes it may be level scales. Lot of displays we are using. Digital panel meter, DPMs. Number of methods are there for displaying the output of a measuring system. Data representing unit. So it can, just now I told you that it can be a scale, it can be a LCD, it can be a signal recorder. Sensors and actuators. What is an actuator? Sensor, you know something. That is, sensor will convert a physical quantity into an output. That means in electrical output. But what actuator do? Actuator will convert electrical input to physical output. Look into the figure. You can see the microphone. Microphone converts. This microphone converts this physical sound signal to electrical signal. Then the output of the microphone strength will be very less. In order to amplify, ज़्यादा करने के लिए amplifier use करता है. So this output is fed to a loudspeaker. Loudspeaker is just the opposite. That means it will convert the electrical input to sound output. Sound output. So this is an actuator. This is an actuator. Loudspeaker is an actuator. Just now it is clear that sensor converts physical quantity to electrical quantity. Actuator converts electrical quantity to physical quantity. Explain everything. This slide is explained. Already explained. Sensor and actuator. Sensor and actuator. Both are required in every physical system. It is required. And transducer is a physical device. In this, sensor plus signal conditioning unit put together is known as transducer. So, transducer is a device which transforms a non-electrical physical quantity, that means temperature, sound, light, level, anything, into an electrical signal, i.e. voltage, current. So that is transducer. You can see input of a transducer is a non-electrical quantity, output is a electrical quantity. So, as I told that in the case of transducer, sensor plus signal conditioning unit put together is known as transducer. This is the input signal, this is the output signal. It's a very simple topic, but it is widely used in the sensors are widely used in the smart world. Everywhere you can see sensors. Suppose you go to a market, go to a shop, automatically what will happen? When you enter into the shop, automatically door will be opening. By how? Sensors. Suppose there is my remote. Suppose I press it, I can increase the temperature. I can decrease the temperature. This are all with the help of sensors. So in the case of washing machine, there is a lot of sensors we are using. In the case of microwave oven, everywhere we are using sensors. Now, so there is a physical representation. How? Here I used analog output. Instead of this block diagram, I can use a DPM. DPM means digital panel meter. Digital panel meter. It will give a digital output, digital readouts. Physical quantity, transducer, output. Okay. Then classification of transducers. Classification of transducers. Based on physical effect, physical quantity, source of energy. Based on physical effect, physical quantity and a source of energy, we can classify transducers. The first classification is based on the physical effect engaged to convert the physical quantity to an electrical quantity. Example, change in resistance of a copper element in proportion to change in temperature. That means, if suppose we are using copper, a temperature sensor. Inside the temperature sensor, copper wire is used. When the temperature rises, copper will expand. Copper will expand. That expansion of the copper is proportional to the rise in temperature. Rise in temperature. So, if temperature, if length is increasing, you know that resistance is equal to R into L by A. So for example, if length increases, proportionately resistance changes. So non-electrical quantity, that means temperature change now converted to length change. In effect, it is converted to resistance change. So physical effect: variation in resistance, variation in inductance, variation in capacitance. Classification based on physical quantity, output. What is the sensor produces different types of outputs. Based on that, a pressure transducer is a transducer that converts pressure into electrical signal. That is pressure transducer. So suppose we go for temperature transducer, what it will do? It will convert temperature to electrical signal. Then displacement to electrical signal. So based on effects, we can classify transducers. Physical quantity converter. That is the end use of the transducer after the conversion. So in the case of pressure transducer, pressure is converted to electrical signal. Classification based on source of energy. We can classify transducer into two. That means active transducer and passive transducer. Source of energy, two types of transducers, that is active and passive. So active transducers are called self-generating transducers. That means there is no requirement of an external power supply. There is no need for external power source to get the output. So that type of transducers are called active transducers. Without any auxiliary source. No need of external source. Thermocoupled piezoelectric transducers, these are the example of active transducers. Whereas in the case of passive transducers, an external or an auxiliary power supply is required to get the output. That type of transducers are called passive transducers. So, example, resistive, capacitive and inductive transducers are example for passive transducers. Example of an active transducer. Thermocouple is working on the principle of Seebeck effect. So in this two materials, constant iron joined together and kept. This is the measuring point. This is the reference point. If temperature rises proportional to the rise in temperature, you can measure the output. Output will be in millivolt. Different types of thermocouples are available in the market. J type, K type. That will be discussing in the next class. Depending upon the applications, we are using different types of thermocouples. So this is a passive transducer. Please look into the figure. It is clear that in order to get the output, it is required external power supply is required. So that is why it is called passive transducers. So this is the point that I want to share with you regarding to the sensors. Which are the points that I have discussed, that we can once again review. What is a sensor? What is a sensor? Tell me. What? Suppose something will be getting you. You just explain what you understood from this session. Sensor will detect the physical quantity change. Okay. The signal conditioning unit. The function of the signal conditioning unit is to, what is the function of a signal conditioning unit? The change that detected by the sensor, it is to be converted into electrical signal. So it is done by signal conditioning. Data representing unit means what is data representing unit? What is your understanding about what is the data representing unit?
The electrical signals is displayed in the
In order to display the output, we require a data representing unit. Actuators. Along with the sensor, I discussed actuator. What is an actuator? Okay, no issue, no issue. What about you? No. What is an actuator? It will convert physical, electrical signal to physical. The transducers. That is also another point discussed today. Transducers. What is transducers? Anybody? Transducer. Sensor plus signal conditioning unit put together is known as transducers. So we classified transducers based on different physical effects, source of energy, output, based on the output or physical quantity. So I think you get some idea regarding to sensors. If you have any doubt, you can ask right now. Okay, shall I wind up? Okay, thank you.
Thank you.